All right, so we've got a lot to go over this week, so this might actually be 2 videos. But we have 5 goals. Our first goal is to be able to define vocabulary over perpendicular and angular bisectors, to be able to use perpendicular bisector theorem to set up and solve algebraic equations, to be able to use concurrency of perpendicular bisectors of a triangle to find missing segment lengths, to be able to use the angle bisector theorem to set up and solve algebraic equations, and to be able to use concurrency of angle bisectors of a triangle to find missing segment lengths. Okay, so here we go. Vocab is the most important part about all of this. So goal 1, super duper important. So first we have our perpendicular bisector. And we know both of these words already. We know perpendicular means an intersection at 90 degrees, and we know bisector means to cut in half. So what a perpendicular bisector is it is a line or segment that intersects another line or segment can't spell at a 90-degree angle at its midpoint. So what that looks like is, let's say we have a line or a segment. I prefer to do segments. Okay? And it has a midpoint. And then we have another line that cuts right through it at a 90-degree angle. That line is considered a perpendicular bisector. Okay? Next vocab word we have is equidistant, which means exactly what it sounds like. It means equal distance. So it's whenever we're talking about these special segments we're talking about, our perpendicular bisector and our angle bisector, cutting segments to where it's creating equal sides. So you'll see that whenever we especially go through our theorems. All right, concurrence is whenever 3 or more lines intersect. Okay? So like right here is an example of something that is concurrent. All 3 of these lines are intersecting at one point. This one point is called the point of concurrency. So this is whenever 3 or more lines intersect. This is where the 3 or more lines intersect. Okay, so like right there. That is the point of concurrency. All right, here we go. Circumcenter. This is the point of concurrency. I'm going to abbreviate. Of 3 perpendicular bisectors. All right, so we're going to be dealing with a triangle. All right. And let's say we have 3 perpendicular bisectors. So we have this one here. All right, and we have this one here, and we have this one here. This point where they all connect, where they all intersect, that is called its circumcenter. Okay? Like I said, this is very vocab intensive this week. All right, we've heard of an angle bisector before. This is just a review, so we're going to talk about it again. This is whenever you have a ray that divides an angle into two congruent angles. Sorry about the bells, guys. I can't stop them. So you have an angle, and then you have this ray that divides it into two congruent angles. That's an angle bisector. All right, and an incenter. This is the point of concurrency for three angle bisectors. All right, so let's say we have our triangle again, like so. Except for this time, we have three angle bisectors. There's one. There's one. There's one. Where they all intersect, this is considered your incenter. All right. So just to let you know, especially vocab-wise, the words that are guaranteed, I mean, all of these are actually guaranteed to be on your test, but it's really important for you to know about incenters and to know about circumcenters. And there's going to be two other points of concurrency you're going to learn next week, I do believe. But for right now, you only know two, and there's four total. 4 special points of concurrency. All right, so let's continue talking about our perpendicular bisector. I like to take the perpendicular bisector when it comes to the theorem. It's talking about if we have a triangle happening and breaking it down into 3 parts. So let's say we have a triangle. All right. When you have a perpendicular bisector, your first part that we'll be looking for is a 90-degree angle, like so. That is one part of your perpendicular bisector, that word perpendicular. All right, the next part is going to be the midpoint, because that's how we know it's a bisector. So you'll be looking for that right angle to be cutting 2 congruent parts, like so. So we have 2 equal parts. This represents our midpoint, because it's in the middle, and our box. And you're like, okay, that's what a perpendicular bisector is. So what's our third part? Third part is equal sides, or equidistant would be our vocab word whenever this happens. And here's the main rule, what you need to remember about all of this. All right? If you have any combination of 2 of the following 3 options, then you have it all. All right? So as long as you have 2 of these, you're guaranteed to have it all. And if you have it all, you have a perpendicular bisector. So remember, if you have 2, you have it all. So let's look at example 1. Here's what we know. We know a 90-degree angle. All right. We also see this right here. This means we have a midpoint. Okay? If we have 2, then we have it all, which means we also have equal sides. So if they want to know what is the length of AB, we can find AB. Here's what we know so far about AB. We know that AB equals 5x. So our issue is we need to solve for x. Well, we know because we have these 2, because up here it tells us if we have 2, we have it all, that these are equal. So we can set them equal. We can say 5x equals 4x plus 3, and then we can simply solve for x. So let's do that. Variables, constants. Ooh, I don't know if this green pen's going to make it all the way. So we have 5x already over here. We need to move 4x over here. We already have 3 over here, and that's all we need. 5x minus 4x is x equals 3. Now, are we done? Is x what they wanted us to find? Nope. They want us to find the length of AB. So we're going to plug in 3 for x. So we have 5 times 3, and our final answer is 15. All right, this is a question on your homework, and I'm telling you right now, when you type in your answer, because this one's not multiple choice, only the vocab's multiple choice. When you type in your answer for this problem and problems like it, you just type in the number, okay? So you would type in 15 and then be done with it, okay? Don't put x equals 15. Don't put AB equals 15. Just put 15. Hope I've made that very clear. All right, let's continue on with our perpendicular bisectors. Okay, now remember the rule where I said if you have 2, you have all 3? So what we're looking for here on these problems is to see if it is a perpendicular bisector. As long as you have 2 of our options, then you have a perpendicular bisector. So let's see what we have. Do we have a 90-degree angle? No, I do not see a box in there. Do we have a midpoint? Yes, we do. See this segment and how these are equal? This means we have a midpoint. So we're good so far. We have one of the 3. We have to have 2. So the last option we have is, do we have equal sides of our triangle? Guess what? We do have equal sides. And remember, all you have to do is have 2 of them, and then you have a perpendicular bisector. So your answer here would be perpendicular bisector. Ta-da! All right. Let's finish up this first video with our goal 3, which is point of congruency with perpendicular bisectors. Hopefully I can fit this in. Actually, you know what? I'm going to stop right there. All right, so this is part 1. Part 2 will also be available, so make sure you watch both of them.